And so it suggests maybe the trajectory of this object was designed by some intelligence.
It begins without warning. In the latest observation window, Comet 3Y Atlas does something it was not doing before. Its coma flashes green, sudden, vivid, and unmistakable. Astronomers watching live feeds see the color bloom outward, spreading like a chemical flare ignited in space. This is not a reflection. It is not dust. It is emission. Something inside the comet has switched on. Scientists immediately recognize the danger of the moment. Green light in a comet means volatile gases, carbon-based compounds are being violently released under solar heating. But this object is different. Hours earlier, the coma carried a duller, red-tinted signature. Now it has shifted. That color change signals an internal transition already underway. Layers that stayed sealed for billions of years are cracking open right now. The comet is not drifting. It is reacting. The timing intensifies the alarm. This chemical outburst is happening only days before the comet's closest alignment with Earth. There is no buffer, no second chance. As 3I Atlas plunges deeper into solar influence, pressure builds inside its nucleus. Buried ices sublimate. Trapped gases escape. Each release permanently alters the object. What is seen tonight may be gone by morning. Once the coma expands and disperses, the original chemistry vanishes forever. Researchers describe this phase as fleeting and irreversible. They are racing against physics itself. Telescopes adjust filters. Spectrometers lock targets. Every hour without data is a loss. This is raw interstellar material responding to our sun for the first time, and the response is accelerating. The comet is shedding its past in real time. What makes the signal more unsettling is what cannot yet be confirmed. The green glow suggests carbon compounds, but the exact mix remains unknown. Are these ordinary comet gases, or something formed in a dead star system long before the sun existed? The color alone cannot answer that. It only tells scientists one thing for certain: the object is no longer stable. And as the glow intensifies, astronomers realize this is only the opening move. The chemistry changing in visible light is just the surface reaction. Deeper interactions are already unfolding, interactions that do not glow green at all, but announce themselves in a far more dangerous way, invisible to the human eye and about to be detected next. The signal did not arrive as light. It arrived as impact. Right now, instruments aboard ESA's XMM Newton are recording X-rays pouring off Comet 3Y Atlas, radiation that should not exist unless something violent is happening. X-rays are not reflections. They are fingerprints of collision, produced only when charged particles slam into matter with enough force to rip electrons from atoms. That means the comet is not quietly passing through the solar system. It is being hit hard. Scientists watching the live data understand the implication instantly. The solar wind, streams of high-energy particles blasting outward from the sun, is colliding directly with gases erupting from an object born in another star system. This is atomic warfare playing out in open space. Hydrogen atoms are being stripped. Nitrogen is lighting up under stress. Invisible chemistry is being forced into view moment by sheer impact energy. This changes everything. Ordinary telescopes cannot see these reactions. Optical light misses them entirely. But X-rays do not lie. They reveal what the comet is made of and how it reacts when pushed beyond its limits. And right now, those reactions are stronger than expected. The X-ray emissions are not fading, they are spreading. The interaction zone is growing as the comet sheds material faster under solar assault. What alarms scientists is not just the presence of X-rays, but their persistence. This is not a brief flare. It is an ongoing exchange, as if the comet is actively feeding the collision by releasing fresh gas into the solar wind. That suggests internal reserves are breaking open now, under conditions no interstellar object was designed to survive. Every data packet arriving from XMM Newton is being flagged, compared, rechecked. Interstellar material almost never exposes itself this clearly. Most pass through unnoticed, faint, and silent. This one is speaking in the harshest language physics allows, and the sun is forcing the answers out. Researchers already suspect these X-ray signatures may become a new method for identifying future interstellar visitors, but only if they can fully decode what they're seeing now. The problem is time. The interaction is evolving fast. The chemistry visible today may not exist tomorrow. And as scientists begin mapping the expanding X-ray glow, a new question is forming, one that was not supposed to be part of this story at all. Because early scans hint the radiation is not confined to the comet itself. Something larger may be forming around it. And that realization leads directly into the next phase of the mystery. The warning did not come from visible light. It came from X-rays. As data streamed in from Japan's XRISM observatory, scientists noticed something that should not be there. A faint but massive X-ray glow surrounding Comet 3-1 Atlas, stretching hundreds of thousands of kilometers into space. This was not a sharp edge or a clean boundary. It was a ghostly halo, wide, diffuse, and unstable, as if the comet were wrapped in an invisible storm. If the signal is real, the implications are immediate and unsettling. An X-ray halo of this scale would mean the comet is releasing enormous amounts of gas, enough to collide violently with the solar wind far beyond its nucleus. This is not passive evaporation. This is interaction on a scale rarely seen, especially from an object this small. Standard comet models begin to strain here. Ordinary comets produce compact interaction zones, tightly bound to their cores. But this halo, if confirmed, suggests an influence field far larger than expected, as if something inside 3I Atlas is feeding the surrounding space continuously. Scientists are struggling to fit this behavior into known frameworks. Caution dominates the room. XRISM is a powerful but delicate instrument, and researchers know that artifacts, background noise, or calibration effects can mimic extended structures. A false halo is possible. But even that outcome is dangerous in its own way. It would expose blind spots in how scientists interpret high-energy data from fast-moving interstellar objects. Right now, teams are racing to separate signal from illusion. Cross-checks are underway. Independent data sets are being pulled in. Every hour matters, because the comet is already changing, and the halo, real or not, may fade before a final answer arrives. If the halo is confirmed, it becomes one of the most significant findings of this entire flyby, proving that 3I Atlas is interacting with the sun in ways no one predicted. If it collapses under scrutiny, it still rewrites how future interstellar visitors will be analyzed. Either way, the story shifts here. Because while scientists argue over what the halo is, missions across the solar system are already moving, scrambling to get closer, faster, before the comet outruns every chance to understand it. And the pursuit is about to escalate. They did not wait for confirmation. The moment Comet 3Y Atlas began behaving unpredictably, the pursuit went global and then interplanetary. This stopped being about one telescope watching from Earth. Right now, assets spread across the solar system are being repositioned, retasked, and synchronized in near real time to track an object that is already slipping away. Mars orbiters were among the first to respond. From their distant vantage point, they captured some of the closest and clearest images ever obtained of an interstellar visitor, watching jets flare and fade as the comet reacted to solar heating. These views reveal details Earth-based instruments could not see: subtle structural changes, uneven outgassing, and motion that hinted at internal instability. Each frame arrived with urgency because every hour changed the picture. Ultraviolet observatories then joined the hunt, probing chemical signatures invisible to optical telescopes. From angles Earth can never reach, they sliced through the comet's coma, detecting volatile releases that appear and vanish in rapid cycles. These signals are difficult to interpret, and that is what alarms scientists most. The chemistry is not behaving like a typical solar system comet. It is reacting fast, unevenly, and sometimes violently. When the comet disappeared into solar glare, completely blinding ground observers, the chase did not stop. Heliophysics missions stepped in, tracking disturbances in the solar wind and faint emissions near the sun's edge. For a brief window, the comet was effectively invisible, yet still moving, still changing. Scientists were forced to rely on indirect measurements, knowing that if they lost the trail even once, it might never be recovered. Months earlier, trajectory refinements from missions like Psyche suddenly became critical. Calculations that once seemed routine are now being used minute by minute, updating pointing commands and observation windows. Tiny errors could mean missing the final usable data entirely. The margin for failure is shrinking. This level of coordination is not normal. It signals something deeper. Scientists know this is a rehearsal. 3I Atlas arrived with little warning, behaved unexpectedly, and demanded instant response. Every data set gathered now feeds future detection systems, faster alerts, and emergency observation protocols. The concern is not this comet, it is the next one. Because this pursuit is exposing an uncomfortable truth. Humanity is still slow to react to fast interstellar intruders. The systems work, but only barely, and only under intense pressure. This comet is forcing weaknesses into the open. And as the tracking tightens and the observation window narrows, a more unsettling realization takes hold. This frantic chase is happening because time is almost gone. The next phase will decide how much of this visitor's story is captured and how much vanishes forever. The countdown is no longer theoretical. It is happening now. December 19th is closing in, and with it comes the narrowest, most critical observation window scientists will ever get with 3I Atlas. This is the moment when the interstellar object swings closest to Earth, fully exposed to solar heat, fully active, and briefly within reach of humanity's instruments. Researchers are watching the clock as closely as the sky. Every hour that passes reduces what can still be learned. Public statements remain calm. Officials repeat that there is no danger, but inside observatories, the mood is different. Tension is thick. This alignment is not about risk to Earth, it is about irreversible loss. Once the comet passes this point, its brightness will drop, emissions will thin, and the signals scientists are chasing will fade into noise. What is not captured before December 19th will never be recovered. There will be no second pass, no correction, no replay. At closest approach, 3I Atlas is expected to react at maximum intensity to solar heating. Buried volatiles may erupt without warning. Chemical signatures could spike and vanish within hours. X-ray emissions may strengthen, distort, or suddenly shut down. These behaviors are already proving unstable. Instruments are being recalibrated daily to keep up with changes that were not predicted even a week ago. This is not steady science. It is reactive science under pressure. Around the world, telescopes are being pulled from other projects and reassigned. Observation schedules are being rewritten in real time. Some facilities are coordinating minute-by-minute coverage, handing off tracking duties as Earth rotates. Space-based instruments are locked onto narrow time slots that cannot be missed. Even so, the comet remains faint. One cloud cover event, one calibration error, one missed window could erase a crucial piece of evidence forever. Scientists describe the next few days as decisive. Not important, decisive. The difference between success and failure is measured in photons. If certain emissions peak and collapse before they are recorded, entire theories about interstellar chemistry will remain untested. If structural changes occur and go unseen, models will be left incomplete. The fear is not that something will happen, but that something will happen too fast to record. As December 19th approaches, the sense of urgency tightens. This is the closest conversation humanity will ever have with this visitor. After that, 3I Atlas will begin to pull away, taking its data, its chemistry, and its unanswered questions with it. What scientists learn now will shape how future interstellar objects are detected, tracked, and understood. And as the comet reaches this critical point, researchers are asking a more unsettling question. What if the most important change doesn't happen at closest approach, but immediately after, when fewer eyes are watching? The departure has already started. Right now, Comet 3Y Atlas is accelerating outward. Its trajectory bending away from Earth and the Sun, carrying its remaining secrets with it. Inside observatories and mission control rooms, the mood has shifted from discovery to alarm. This object is not fading quietly. Instruments are still picking up irregular chemical signatures, carbon compounds breaking apart faster than models predicted, traces of nickel appearing where none were expected, and volatile gases reacting violently to diminishing solar heat. The behavior does not fully match any known comet template. Scientists are watching an interstellar body shut down its activity unevenly, like a machine powering off in the wrong order. X-ray analysis has intensified in these final moments. Researchers believe this is the last chance to detect elements that may never again be measurable at this proximity. Some signals appear briefly, then vanish between observation windows, leaving incomplete data sets and unanswered questions. Was that emission a rare isotope or noise masquerading as structure? Was the chemistry native to another star system or altered by its passage through hours? Each missed hour means a permanent loss. Once the comet's interaction with the solar wind weakens, the diagnostic tools go blind. What remains afterward will be silence and inference. It might have gone unnoticed until it was already gone, or worse, until it was too close to respond to. This is no longer just astronomy, it is procedural risk. Survey systems, tracking algorithms, and planetary defense models are being quietly stress-tested against what just happened. Surichata 3I Atlas is leaving behind more than data. It is leaving behind doubt. It arrived without warning, behaved in unexpected ways, and is now exiting before its full story can be told. Scientists know this was a rehearsal they did not plan for. The next interstellar visitor may not glow green, may not emit X-rays, may not announce itself at all. And as the comet fades into the dark between stars, one question remains unresolved. What exactly will follow it out of that same silence?